All right, we'll go ahead and get started here. Again, this is going to be the WinMax conversational 3D mold and swept surface training session. We're going to go over both 3D mold and swept surface. When you get the 3D option on the WinMax control, it's automatically going to come with both options, the 3D mold and swept surface. We'll start with 3D mold. We'll cover that, and then we'll kind of move into swept surface and show you what can be done there as well. 3D mold was the original 3D option with Hurco. Way back in the Ultimax machines, we did have 3D mold, and then when we went to WinMax, it allowed us to expand on that a little bit and add swept surface, which gives us a few more things that we can do and a little bit easier as well. There are still a couple things that you will want to use 3D mold for. So through this presentation, we'll make sure you understand when you're most likely to want to use 3D mold and when you're most likely wanting to use swept surface. Once you've been showed the option and worked through a couple, they are relatively easy to use and understand. Especially once you get into the swept surface, when you first open that data block, it can be a little intimidating because of all the options we have. Well, there's a lot of power with that swept surface option, so it just requires a little bit more information. But once you get in there and you kind of start to understand what you have to work with and what you can kind of leave alone based on your geometry, it eliminates the majority of those options and really makes the block less intimidating. So we'll go ahead and just kind of jump right into this. Like I mentioned, we're going to start with 3D mold. What you're going to do in 3D mold is you're basically going to define a 2D contour, and you can see I kind of highlighted the geometry here, and then you're going to translate that in some method. You're going to transform that contour into a surface. If you look on the left-hand side of the screen here, you can see the options that we have. We have revolved about X, which would be revolving around the X-axis, revolved about Z, or translated in Y, and of course you can always combine those to make a little bit more complex parts. What we have here in the center of the screen is an example of revolved about X. We would have defined this contour here, and then we would take that and tell it that we want to revolve around the X-axis to give us this surface here. If you look over here on the right-hand side of the screen, this is actually a part that I'm going to walk you through here in just a second to explain how the 3D mold option works. One of the other options we have is revolved about Z. You can see we defined the same contour, and this time here we told it to revolve around the Z-axis. If you look at the part we have pictured here, this corner, that would be a revolve about Z. You would just program this arc here and then tell it you want to revolve around this point around the Z-axis. We also have translated in Y. Basically, take the same contour, tell it you want to translate in Y, you give it a start and end point, and that's how we would program something like this side of that surface. You'll notice that all we have is translated in Y. There's nothing with X here. So if I wanted to use 3D mold to create this entire part, I'm going to have to use some patterns in order to get my geometry where I want it on the part. That's something that has been taken care of with swept surface. So this particular part here, we can do 3D mold. However, swept surface is probably going to be the method of choice if we were to program this part that's pictured. And again, we'll get to that a little bit more in the presentation. So the basics of 3D mold is you're going to go ahead and you're going to define that contour. In all those examples before, we just defined a simple 2D contour. So you'll go into your data block, it'll tell you want to draw a 2D contour. You'll then select either the rotate around X, rotate around Z, or the translate in Y, and whichever one you select is going to bring up the parameters it needs to be able to complete that surface. So in this example here, it shows a translate in Y. It just basically needs to know where you want to start in Y and where do you want to end. Some of the basics, retract clearance is going to be the only program parameter that's going to be used by the 3D Mold software, with the exception of your performance tab. It's still going to look at your SFQ settings if you have that option. But for the typical parameters, retract clearance is going to be the only one that you have to worry about. As far as the tools that you can use either a flat or bullnose end mill or a ball end mill. You can see when using a flat end mill, you have to kind of take into consideration how the control is going to treat that. When you go and take your tool and touch it right off your part, the control is going to treat that as though it is a ball end mill. So it's going to create a radius here on the end. So you can use the flat end mill and bull end mills. You just have to be careful to make sure that you're not going to leave too much excess stock to come in and clean up with your finish pass. But it does give you the ability to use flat and bull nose end mills to rough out your surfaces.
As far as using a feed mill, we could do that. That's basically lie to it to rough it in, and then you can use a ball end mill with a finish, correct?
Yes, yeah. If you were wanting to use a high feed mill or something like that, it would work the same as if it was just a flat tool. It's just going to add the radius into the bottom. And that's to keep the tool from gouging the surface where it shouldn't. Here we show a ball end mill. It's going to work just as though you would expect it to. If you touch it off the part, that's how it's going to calculate the tool path as well.
On that flat tool, we don't need to lie to it on the length or anything.
No, you wouldn't want to do that. You'd want to touch it off just like normal. That slide was really put in there just to let you know that it was going to compensate. You wouldn't want to go in there and then lie to it and bring it down. Otherwise, you would probably end up gouging your part a lot. You know, going farther into the surface than you wanted to. To eliminate that gouging is why it creates that theoretical ball end mill on that tool.
For instance, if we were starting with a 1-inch end mill, we touched off, we'd basically put a half-inch radius, add a half-inch radius to that. We would touch off and then raise it up on the Z.
No. It's going to do everything for you. So you're going to touch it off the same as if you were going to use that on a flat geometry. The control is going to do all this for you. You don't have to worry about any of that. As soon as you start a 3D mold or swept surface data block, it's going to do this on its own. And again, it's just to prevent gouging of the tool. So you touch it off like a normal tool, and when it goes to be used inside one of these 3D data blocks, it'll take care of all that for you. You don't need to concern yourself with any of that. Just wanted to point out what it was going to do in case you ever, were using a flat tool and wondering why it seemed to be lifting itself up a little bit.
Okay. But it only does that if you don't describe a end mill, a flat bottom end mill, correct?
What's that?
If you're roughing with a ball nose, it will not add that in there, will it?
No, it'll treat a ball mill just like you would expect it.
Okay. Another quick question too, in your program parameters, your retract clearance, you said that's the only one it uses. What do you set that to?
The retract clearance is the same as any other data block. What that wants to know is when you're moving or positioning from one data block to another, or with pec depth, how far do you want to lift above your part 0? So it's, again, just the safe region that you would use for anything else. A lot of people will set it to 1 inch or a ½ inch. Wherever if the top of your part is Z0, that retract clearance can be pretty much anything, because it's going to go from your Z start. Now, if the bottom of your part was Z0, however thick your block is, you want to make sure that your retract clearance is at least larger than that.
But there's no special consideration than any other program?
No, it works exactly the same. It's just that that's the only parameter it's going to look at when in a 3D mold block.
Okay. Everybody okay?
So we're going to go ahead and we'll walk through this this print here. What I've pulled up here is my desktop software. This is the same software that you would have on your machine, so I can just kind of go ahead and walk through this contour with you. So I'll start off. I'll go into my program manager. I'm going to start a new program. This will be a conversational program. I'll start off by putting some stock geometry in. That way I can make sure that what I program is positioned correctly on the part. Give it some stock geometry. It looks like we have 4 inches in X, 3 inches in Y, and a half in Z. So we've got some stock geometry in. Now I'll go in and program.
Hang on one second, Jason. That's where
Yes.
you go to manually set up your stock size. It's for graphics purposes only?
Yes. Yeah. What the stock geometry does is, since we're going to have the 3D solid graphics once we hit the draw button, it gives us the ability not only to tell it what tool we're using and what program or part we want to cut by our part programming, it also gives us the ability to tell it what size stock we're going to put in the machine. What it's meant to do is, if you set all 3 of those things up, your graphic screen should look exactly like the part that you intend to take out of the machine. I like to put it in, if I forget minus signs, or maybe I make something too large. The example I like to fall back to is, if all I'm doing is cutting a circle in the center of a piece of material, if I give it the diameter rather than the radius, it's going to cut that circle twice as big as it needs to be. Well, if I have not defined my stock geometry, a circle is going to look like a circle. So by defining that stock, if I see it milling off the part, I know that I've done something wrong, and I have to go back in and check something. And once we get some graphics up, we can show you a little bit more about that as well. So I'm just going to go into my part programming. Typically on the machine, you're probably going to hit input, part programming. These are milling operations, so I'm just going to go right into milling. And 3D mold should be on your first list in your soft keys here. So I'm just going to go right into 3D mold. You'll see we're now in a 3D mold block. The first thing that it's wanting us to do is to draw that 2D contour. I'm going to go ahead real quick and put in a tool that I want to use, and I'll explain why I did that here in a second. And we'll worry about the rest of these parameters here in just a minute. But I just told it that we're going to use a 1/2 inch ball end mill. So as long as this says draw 2D contour, I'm going to go in my soft keys. I'm going to tell it that I want to edit that 3D mold contour. And once I do that, we're basically just in lines and arcs, the standard lines and arcs that you would always have. And I'm just going to go ahead and define just half of this contour here. We'll stick with the upper portion, the same as if it was just a standard 2D contour. So my X start, looking at the print, looks like it's going to be a 1/2 inch in X, and my Y is going to be 1.5 inches. We're going to start right at that point there. I'm going to go to my next segment. First segment will be this arc. I'm just going to go ahead and choose arc. It is a clockwise arc, so we can leave that set at clockwise. As far as my X and Y endpoint, the first 2 things it's wanting to know here, without doing quite a bit more calculations than I want to do right now, I really don't know where that arc ends and this kind of blend arc is going to begin. So I'm going to leave the X and Y endpoint blank. We're going to let the control deal with that information. I do know the center point of this arc. For X, it's going to be the 1-inch radius plus the 1/2 inch here. So it's going to be X center 1.5 and Y center 1.5. And you'll see it calculated the correct radius. So most likely we're good so far. I'm going to go to my next segment, and I'm just going to program this with a blend arc. You know, I'm not given the center point or anything like that. So I'm just going to tell it this is a blend arc, and then it's a 1/2 inch radius. Next segment is going to be this line. Go ahead and select line. Now I'm just going to go ahead and program this line right out to this theoretical sharp corner. And again, I'll just use a blend arc after I'm done to get that radius in there. So just dealing with this line now. The X end will be 3.5. Y end, it's a 1/2 inch above center, so that'll be 2 inches. And you'll see it calculated the length and the angle. If I look at the angle here, saying it's -14 degrees, if I look at the print, it's telling me that's supposed to be a -5 degree angle. So I'm just going to go ahead and put in the -5 degrees. And it recalculated the length for me. I'll go to my next segment. I'm going to use a blend arc to round this corner, and that is a 3/8 or 0.375 radius. Next segment will be a line, and we're just going to take it to this end point down here. X end will be 3.5 and 1.5 in Y. So we've defined the contour. Any questions on how I did any of that? Does that kind of make sense to you?
Yes.
Just basically a 2D contour. The reason that I went ahead and put in my tool to begin with, if I want to go to my graphics in 3D mold, as long as I have my solid graphics turned off and I just have only my tool path, as long as I have a tool in there, it'll show me that contour. So I usually go ahead and put my tool in first, program the contour, make sure my graphic settings are set just the tool path, and then it'll at least show me if I've programmed that contour correctly. That way, before I ever mess with anything 3D, I know if the geometry I've programmed is good. So that looks good. So now I can go deal with the 3D portion of this. I'm going to go back into my part programming. Now I'm done with this contour, so I'm going to go into my soft keys and tell it I want to edit the 3D mold parameters. That's going to take us back to this main screen. So now what it's wanting to know is, what do we want to do with that contour that we just created? I can either hit the drop-down menu here or highlight the field and then use my soft keys, but I want to rotate this around the x-axis. So I'm going to go ahead and tell it I want to revolve around x, and then it's just going to bring up the parameters needed to rotate this geometry. It's going to give me a start and end angle. I'm going to put this in at -180 degrees. We'll talk about these angles here in a second. Z-start is the same as Z-start on any other geometry, just how far above your Z-start you want to, or your part you want to start. And then it wants to know what point do we want to rotate around. It's going to give us the option for Y and Z. I just want to rotate right around the center point of this part, so I'm going to put 1.5 inches in there for Y. And my Z, I'm assuming, is the top of this part. That's the point I want to rotate around, so I'm going to leave that at 0. Down in this lower portion, we have a few options. The first one is cut direction. I believe I have a slide here that'll talk about this. We're going to have two options: follow the 2D contour or normal to the contour. If this were the contour that we programmed, if we told it to follow that 2D contour, as it's cutting, it's going to follow that contour. It'll step over, come back, so it's always going to follow that contour that we defined. If we choose normal to the contour, it's basically going to cut at right angles to that contour. So instead of following this way, it's now cutting in this direction here. And I guess I should ask, when I'm moving my cursor on the screen, you are seeing the mouse move, correct?
Yes.
Okay, just wanted to make sure that you weren't thinking I'm crazy quite yet. But that's the two different options, and we will talk about them again once we get into swept surface, but it'll basically do the exact same thing. So that's the cut direction. I'm going to go ahead and we'll leave it with contour for now. We'll change it in the graphic so you can see what it does. We have this bidirectional. What this wants to know is when we're cutting, once you make one pass, you just want to step over and then make a pass back. That would be bidirectional set to yes. If you leave that set to no, it's going to make one pass, retract, go back to the start, and then make another pass. So I typically set this to yes. We've got the step size over here to the right. This is wanting to know, how far do you want to step over in between each one of these passes. I'm going to leave it somewhat coarse here. I'm going to go with a 50 thou step over, just to allow the graphics to run a little faster. Of course, you can take a pec depth if you want. It works just like any other data block.
Hey, Jason, we got
We also have the stock allowance down here. A lot of times what guys will do is they'll go ahead and program a 3D mold block, leave some stock allowance, say 20 thou or whatever they want to leave, then copy that data block into the same program, and then basically create a finish pass out of it. Just eliminate the stock allowance, maybe knock down your step size, and get rid of your pec depth as well. So that's the reason for the stock allowance. Also, if you were going to, maybe create a surface, then send it out for heat treat, and then you wanted to finish it in the hardened state, you could just put some stock allowance in there to make sure that your surface was larger than what it needed to end up, so you'd have a little material for after the hardening.
Jason.
Yes.
Jason, we got a question?
Yeah.
Okay.
We were talking about the step over a while ago. Is it going to, basically, conventional mill and climb cut at the same time, or is that what you was talking about, or is it going to start?
If you have your bidirectional set to yes, it will conventional and climb mill. If you leave it set to no, it'll just climb mill.
Okay.
So we're done with this 3D mold block. I'm going to go ahead and run my graphics. I draw this. Of course, I'm in my tool path, so all we're seeing is the wireframe here. I go into my graphic settings and tell it I want to see everything, both toolpath and solids. I should get a solid rendering of what we just programmed. And that is our 3D mold block. And you can see with the direction I had it set to, if we go ahead and change that to be normal to it, you notice before it was cutting in this direction. If I switch that, it's now going to cut in this direction. And I have no pec depth in here, just so it's taking it all at one shot. If I did have the pec depth, it would obviously step down by whatever your pec depth was, machine that out, and then step down to the next pec depth as well.
Hey, hang on real quick. Hey, Jason, what did you change to get it to go the other way? Oh, the cut direction? Okay.
Cut direction.
Okay,
Normal or follow.
At this point, can you click the Finish tab and use that for a finish cut?
Yes, that'll work the same as any other data block. You can click on that, give it same tool or a different tool, and then that'll take it to size.
And
also,
you control the step size there also?
Yeah, it'll ask you for a finish step size as well. So that would be, go ahead.
Also, if you start, I know you just plunge down, basically you're just showing what it would do, taking it all in one cut, but if you, theoretically, if you just step down, you cut a lot of air, am I correct?
No. And let me talk about the roughing and finishing here for just a second.
Okay.
And then we'll go show you that. They actually have changed something here relatively recently. It used to be that when you were doing your roughing and finishing, you were stuck with the same cut direction. And that's why a lot of guys would copy and paste. I see now that in the Finish tab, we have the option of changing our cut direction. So the copying and pasting, you probably won't be doing as much anymore, because now you can just change a cut direction in your finish pass and give it a tool number. And you can change from bidirectional yes or no in your finished pass as well. So they've kind of added a few more features in here, so the copying and pasting probably won't happen quite as much. Now, going back to the pec depth, let's say I put in 150 thou pec depth. If we watch this cut now, he's going to step down 150 thou. It's not really like it's just taking that surface and stepping it up a bunch of times. It's still calculating what it needs to do in order to rough that out. So you're not going to end up with a whole bunch of air cuts.
That's what I was wondering about it, on the edges, if you're only going 10 thou on the first pass. Like, she's getting a smaller pass. Yeah.
Unless you can programming, they'll end up making you doing, you know what I mean?
Start up here.
Yeah, and you'll be barely touching this little bit of the bottom until you get to go there to delete all that. Make you double the time.
So that's basically how 3D mold works. You see the process there. You define a contour. You then tell it how you want to transform that contour, either translating along an axis or rotating around an axis. And of course, you've got the parameters down here to kind of fine-tune the way that's going to cut. This minimum Z that we have here, I have a slide a little bit later on when we're talking about swept surface that'll help explain that. So we can kind of forget about that for now, and I'll clear that up a little bit later. So that's the revolve about X. The next thing that I'm going to show you, here's another good example of revolve about X. We would just go in and program half of this contour and then tell it we want to revolve around the X-axis to get that fully revolved shape. I'm going to walk you through this one as well with 3D mold. Now that we do have the 3D mold and swept surface option, this particular part would be something that you would most likely want to do with swept surface, and we'll show you the reasoning behind that a little later. But I'm going to show you first how you would do it with 3D mold. So I'm just going to bring back my desktop software, start a new conversational program. I'll go ahead and put some stock geometry in there, which again is completely optional. It does allow me to make sure that everything that I've put in was put in correctly. So I went ahead and just jumped right into my part programming. Again, I'm going to go into milling and 3D mold. So the first thing that I need to do is go ahead and draw this contour that I want to transform. So I'm going to go ahead, again, I'll put in my tool number, and then I'll tell it I want to edit the 3D mold contour. Now, basically what we're going to do is we're just going to go define just this contour here. So if I go into my data block, the X start is going to be 0.75, and Y will be 0. Now, when you're working with 3D mold, once you set it to be a 3D mold block, either rotating or translating, basically what you're doing is swapping the Y out with the Z axis to create that 3D contour. So I've given it this start point. I'm going to go to my next segment. I'm going to choose arc. This is a clockwise arc. So leave that clockwise. X end will be 0. Y end will be minus 3/4 of an inch. X center 0, and Y center will be 0 as well. So we just defined that arc right there. I now want to go into the Edit 3D Mold parameters. And the first thing I'll do is I'll create this left straight edge. So I'm going to tell it that I want to translate in the Y-axis. I'm going to tell it I want to start right here at Y 0.75, and I want to end up here at Y 5.25. And we'll start a little bit above the part. I'm going to have it cut normal to the contour, and we'll go ahead and say yes, I want to do bidirectional, and I want to make sure I give it a step size here. And when I go ahead and run my graphics, you can see that we've got that side programmed. So now what I want to do is go ahead and program just this top corner as well. I'm going to go, instead of recreating anything, I'm actually going to go into my review screen. If you were to hit the review button on your control, this is where it would take you. I'm going to go in multiple block functions. I'm just going to copy this data block, and we'll paste it right in the program. So I have 2 blocks that are exactly the same. I'll just go edit this second 3D mold data block to get it to rotate around the Z-axis. Since I'm still using the same contour here, I can just copy and paste this block and make whatever changes I need to. So instead of translate in Y, I'm going to set this and tell it I want to rotate around the Z-axis. I want to take this and essentially just rotate around the Z-axis. My start angle, I'm going to start at 0, and I'm going to go to minus 90. One thing I meant to point out on the previous part was it takes a little getting used to these angles. Sometimes you'll have to play with them a little bit to see if you want this to be a negative 90 or a positive 90. But the beautiful thing about the graphics is you can just go ahead and set it, press your draw button, and you can see what it gets you. After a while, you can visualize it, but it does take a little getting used to know if you want a minus 90 degrees or a positive 90. But that is part of the beauty of the graphics. So now that I told it I want to rotate about Z, I need to tell it what point in Z. My X is going to be 0.75, and my Y will be this 5.25. If I run my graphics, we should see if I've done everything correctly so far. And you can see that we've got that radius. So I'll go ahead. You notice that we didn't have any options for translating in the X direction. So one of the limitations of 3D mold is that if we want anything along the X-axis, we're then going to have to apply our standard patterns in order to get that geometry where we want it. So in this case here, I'm going to go ahead, I'm going to insert a block before both of these data blocks, and we're just going to rotate both of these blocks around the center point of this part to get it on all 4 sides. So I'm just going to insert block before, we'll go into patterns, our loop patterns, and we're going to use a loop rotate. I want 4 repetitions of this geometry. I want it to rotate around the center point of this part, which is 3 inches in X, 3 inches in Y. I'll go ahead and tell it I'm going to start right at 0 degrees, and I want to rotate 90 degrees. So I want 4 repetitions, 90 degrees apart. Whenever you start a pattern, you remember that you have to end it. So I'm going to go to the end of my program, go back into patterns, and tell it pattern end. Now when I go run my graphics, see we've got the complete part. Now one thing that you'll want to notice here is how it cut that part. When we programmed this, we programmed it each section kind of as its own data block, and then we patterned it. So what it's going to do is create the first part, or the first piece of the pattern, and go to the next. So it's not going to be one nice smooth rotation all the way around this part. That's another thing once we go to the swept surface that we can do. It'll smooth out the motion a little bit. But that's how you would do this in 3D mold. And of course, we'd probably want to program something to come knock these corners down. But other than that, we basically have a completed surface. With 3D mold, this still wasn't a bad way of programming this. This part actually worked out pretty well because it was a square part. If we had more of a rectangular type part, we'd have to do a little bit more work in order to get these x-axis translations. We couldn't just pattern around a single point. We'd actually have to rotate it and then move it into position. So just a little bit more work, but it can be done. And that, of course, is how we would program that with 3D mold. What we'll do here in just a few minutes is we'll go through and we'll program that same part in swept surface so you can kind of see the differences and maybe some of the advantages of using swept surface for this particular type of part. Because of the limitations of only being able to translate in Y, typically you'll find yourself using swept surface for anything that looks like this, where you're going all the way around multiple sides, and typically using 3D mold for anything that you want to rotate around. If you want to rotate around the x-axis, you're still going to have to use that 3D mold. But for anything else, you'll probably find yourself going towards the swept surface. So we'll go talk a little bit about swept surface now, show you how it works. What you're going to do with swept surface is you're basically going to program 2 contours into one data block. Every swept surface block will have 2 contours in it. You're going to have a profile contour, which is what we're showing here, and an along contour, which is kind of what we're showing down here. The profile contour is going to be swept around the along contour. The way I've heard some people refer to this is if you were working with a router, a wood router, the profile contour would be your router bit. This is the shape that you want to cut into your part. And then the along contour would be the edge of your part or the template that you want to follow with that router bit. So you can see in the part here, we're basically taking this profile contour and we're sweeping it around or along the along contour to get this 3D surface. So for every swept surface block, you will have 2 contours. I'm going to start off and we'll just go ahead and we'll program this. Once we have that, we'll go in and talk about all the different parameters that we have available to us. We'll go back into our desktop software. I'm going to start a new conversational program. Again, I'll go set up my stock geometry, just as kind of a double check for myself to make sure that I am doing exactly what I think I am. I'm going to go into my part programming. Again, I'm going to go into milling, except this time you'll notice you have to hit more. It's just on the following set of soft keys. And we're just going to go into swept surface. There's going to be 3 different areas that you're going to have to deal with when you go into a swept surface. You can see if I highlight this, I can either use the drop-down menu or I can look in the soft keys. We're going to have to deal with the profile contour or contours, which we'll explain here in a second, the along contour, and then the swept surface parameters, which are going to kind of be the fine detail of how you want to cut this surface. We'll go ahead and start with our profile, which you remember was kind of like the router bit. We'll go ahead and tell it we want to draw the profile contour, and then we just simply tell it we want to edit. So right now it tells us we're in a swept surface block, and it is a profile contour. So again, I want to define this same arc here, but there's one thing that you kind of have to remember with swept surface, and that is when you're defining your profile contour, it does not want to see any negative X movements. So if I were to define this just like we did in 3D mold, that would obviously be starting at this 3/4 inch in X and going in the negative direction to 0. Since it doesn't like that, it doesn't want to see any negative X moves when defining the profile, I'm going to go ahead and define this, starting at the center point here and going in this direction. Once we go into our along contour, we will just simply tell it which side of the along contour do we want it to cut. And once we get through this, you'll see how that works. It probably sounds a little confusing at this point, but we'll clear that up.
Hey, Jason, hang on 1 second. We got a question.
Okay.
Can I work off the center of the part and then just program it to the right side of the part instead of the left to start with?
Say that again.
If I'm working off center of the part, can I do that here so I don't give it any negative numbers? Just program the radius over to the right side?
Yeah, you could do that. You could program it over to this side if you wanted. But basically, when we define the along contour, we're going to use this here. So all we'll do is define that and then tell it we want to cut on the left side of that line rather than the right. And when we do that, it basically creates almost like a mirror image of the part on the left side of the line. And you'll see that here in just a second. So I'm going to put my X and Z start. You'll notice that now that we're in a swept surface block, it's going to go ahead and start right off with Z here, which is still doing the same thing that we were doing in the 3D mold. It's just now labeling that as the Z start. So I'm going to start right at this point here. We'll go to our next segment, which is going to be an arc. This time we're going to go with a counterclockwise arc. And we'll just give it the end point. The X end will be X750. The Z end will be minus 750. X center be 750, and the Z center will be 0. So we're basically rotating an arc around this point in a counterclockwise direction. So that's all we need for our profile contour. You'll find that when you work with swept surface, to navigate around, it's usually best to go through your review screen. So if I were to press the review button on the control, which is the same thing I've got there, it takes us to our review screen, and you can see that I've got the profile contour here and the along contour. Remember, you're going to have 2 contours in every swept surface block, and I can go right to the swept surface as well, so it makes a little easier navigating. As of right now, you can see we don't have anything in our along contour, but we have programmed that arc in our profile contour. I'm just going to go back to the swept surface. I like to work from this screen here. So I'm going to tell it I want to now work with my along contour, highlight that, tell it I want to edit the along contour, and now I'm just going to go ahead and define this along contour here. Usually, wherever you put your 0 point of your profile contour, that's usually the contour that you want to choose for your along contour as well. It doesn't necessarily always have to be, but it makes working with swept surface a little easier. So since I defined the start point of this arc, and that'll be riding around this point on the along contour, that's the geometry I'm going to choose for my along contour. For my surface side, I'm going to tell it I want to cut on the left side of this contour that we're getting ready to program. And we'll just go ahead and program that in. I start at x.75, y.75, so we're starting right at this point here. Next segment will be a line. X end will be 0.75. Y end will be 5.25. Going to take a line, again, 5.25 in X, 5.25 in Y, and we're going to come straight down with that. So we're going to end in Y at the 0.75. Now create another line to take everything right back to our start point. We basically just created this square. So I'm going to press the review button again. Excuse me. We'll go into swept surface. So I've already worked with both my profile and my along contour. If I go back to that review screen, you can see I do have something in my along contour now and something in my profile. So now all I need to do is go back to the swept surface and edit the parameters to tell it how we want to cut this part. So I'm going to go down to my swept surface parameters, and it brings up the swept surface page. This is typically where a lot of people start to get a little intimidated by swept surface. You know, it's asking for a whole lot of stuff right off the bat. The nice thing about it is the majority of these we're not going to use, especially for this part here. You know, there's a lot of power in this data block, which just requires, you know, a lot of input. But for a lot of your parts, you're not going to need all these options. So what we'll do first is we'll just go ahead and deal with what we need, and then we'll go back and explain some of these other parameters. Excuse me. Go ahead and give it my Z start, and I'm pretty much going to ignore everything in this upper portion for right now. We don't need to mess with any of that. I'm going to give it the tool that I want to start with. We're going to go with that 1/2 inch ball end mill that I've been using. Excuse me. Cut direction. We've got the same options that we had in 3D mold as well as a spiral cut, which gives us the option of basically ramping all the way along this profile, which I'll talk about here again in just a second. I'm just going to set it to normal. Bidirectional, yes. You'll notice a lot of these parameters are the same as what you would have saw in 3D mold. And we'll give it a step size. So we'll go ahead and we'll check our graphics here, and then we'll deal with the rest of these parameters. So now you can see that we've got the same geometry that we just programmed with the 3D mold. However, we programmed it with swept surface. You also notice that, you know, in 3D mold we had to use basically 4 data blocks to get this geometry. Well, here we just used the one. And one of the biggest advantages, I think, is now our tool path. You'll notice that when it cut this, it was cutting all the way around. There was no more of, you know, cutting just one side and then cutting one radius and going on. It's going to create or cut the whole thing as one surface. So you get a a little smoother tool path out of the swept surface. So now what we'll do here is we'll go ahead and we'll walk through all those parameters that we just skipped over. For this part, the majority of them don't apply, but we'll go ahead and we'll explain them and then maybe come in and use a few of them a little bit later.
Hey, Jason?
Yes?
Is there a way, like on the print, on the top square there, you've got 90-degree corners, but on the drawing, you have radiuses on the corners on the top. Can you square those corners?
So basically, could we go in and knock these corners off?
No. The top part of
Z0.
your Z0.
On the 3D mode, you had 90-degree corners. And
Okay, yeah.
On the swept surface now, we have radius corners.
So up here?
Yeah.
Yeah. We'll talk about that here in a second, how it's doing that, or why it's doing that. We've got a few slides here coming up that'll explain that. We'll start off with this roll start point and roll end point, and then we'll get into the parameter that's going to affect the question you just answered. The roll start point and roll end point, if you look at, this is coming right out of the programming manual. It says roll start point, when yes, sweeps the profile down to the horizontal plane at the start point. And we've got a very similar description for roll end point. I've got a graphic here that kind of clears that up. What this deals with is when you have a open-ended contour. What we just programmed, that was a closed contour, so this parameters don't take effect. But if we had an open-ended along contour, in this case, that arc would be our profile, and this line would be our along contour. Well, since that's an open contour, it gives us the option of rolling the start and the end point. With both of them set to no, you're going to get just what we see here in the graphic. Whatever we program, that's where your surface is going to end. If we come over here, tell it that we don't want to roll the start point. See over here we have a flat, it just ended where we started. But we tell it we want to roll the end point. At the end of that along contour, it's basically just going to roll that profile down to your start point. And you can see over here what it looks like if you roll both the start and end point. So if you have a open-ended along contour, it just gives you the ability of kind of wrapping or rolling that profile down to your start point. So that's roll start and roll end point. The next thing we're going to talk about will answer the question that you asked here. It wants to know the type of corners. It tells you the type of corner, rounded, extended, or truncated to insert when there is a change in direction in the draw along contour. So if I go to the graphics here that we created to kind of help explain this, what it wants to know, when there's a change in direction, a 90-degree corner here, how do you want to handle that surface that you're creating? Excuse me. The first option, which is typically the default, is radius. It's just basically going to offset out this surface, and where it offsets, it's basically going to connect the two tool paths with the radius. So it's going to round those off. So you end up with like a rounded or conical corner. We have extended here, which is basically going to do the same thing. It's going to offset all the tool path, and then it's just going to extend that tool path out to make that sharp corner. And then truncated is a little different, but what this wants to know is what this is going to do once you offset out, it's just going to connect those tool paths with a line, so you end up with kind of a pyramid shape. You've got kind of a flat transition there. So that's the That's the parameter that deals with the corners, how you want those corners to turn out. You'll see we have a lot of other parameters here. We're going to talk about several of these. First thing, the Z-start is the same as how you use it in every data block. It's just the Z coordinate at which the Z plunge feed rate begins. It's also where your coolant is going to turn on, those kind of things. Your step connect type, you see the type of segment, an arc or a line, to connect passes of normal cut direction. If you remember the normal cut direction, it's going to go all the way around this profile. What it wants to know is when it comes time to step down to the next path, do you want to connect that with a line or an arc? If you were working with a CAM system, majority of all of them have this same option. If you want to connect with a line or an arc is typically used more to help keep smoother motion and used a lot of times in high-speed machining so that you're never making the sharp transition. The use cusp height, you can see that it says when yes, step over is calculated from the specified cusp height. Everything we've done so far, we've just been entering a step size in this lower portion of the screen. We have the option of using the cusp height. And if you're not familiar with the term, you know, when you're cutting with a ball end mill on a surface or whatever, based on your step over, it's going to give you little cusp, you know, little cusp in your part. What this wants to know, do you want to program with the step size? Or if you set this to yes, instead of having step size here, it'll ask for the cusp height. So you can program off of the desired cusp height. If you set that to yes, it's then going to look at this minimum cusp overlap, and this is going to be a percentage of your tool, but basically it's going to limit your step over. So if you put an extremely small cusp height in there, that you're not going to get, you know, a ridiculously small step over on your cutter. We also have the pocket first here. You'll notice that on the bottom of the page, we have the roughing and finishing that we're used to. We also have a pocket tab, which we're going to use here in just a little bit. What it gives us the ability to do is set this swept surface up as a pocket. If you are pocketing, this just wants to know, do you want to cut the pocket first or the swept surface first? Typically you want to go in, cut your pocket first so that you're not taking such heavy cuts when you're cutting that swept surface. We also have the option here for individual profiles. This allows us to program different profile contours to be used for individual segments along or with the long contour. I'm going to give you an example of this here in just a few minutes, but the best example I can think of is, say you just had a pocket, and just a square pocket, and you had 1 degree of draft on 2 of the walls and 2 degrees of draft on the other 2 walls. You could use individual profiles, actually set up 2 different profiles, and complete that part so that you have the different draft angles. And don't worry about that a whole lot for now. We'll go ahead and walk you through that in a second. Again, we'll talk about the cut direction. Again, this is the same as what we had in 3D mold with the addition of the spiral. Of course, we got the cut with contour. On this part here, it would basically cut with that arc that we programmed. If we choose normal, you see the toolpath follows the part at right angles to the contour, so it would cut going around this surface. We also have a spiral cut direction in swept surface. What this will be is a constant ramp from start to finish. So you're going to have an XYZ toolpath here. It'll just continually ramp down the part as it cuts. Because of this new cut direction, occasionally it can be beneficial to program 2D geometry with a swept surface. Let's say, for example, I just had a standard square shape that I wanted to cut, but I wanted to utilize this spiral toolpath. I could just go ahead, sorry about that, I could go ahead and program that 2D geometry as a swept surface, just make sure that my profile was a straight line. I could then apply this spiral toolpath to that 2D geometry. So occasionally it is beneficial to program even 2D geometry in 3D mold, or I'm sorry, swept surface. The minimum Z field that we had both in 3D mold and swept surface that I said we'd talk about a little later, this is the screen I want to use to show that. What minimum Z gives us the ability to do is limit how far the tool is going to go into the part. Let's say, for example, that we programmed a drafted pocket. If this was our profile contour, this red line here, if we just ended it right at that point, with our minimum Z set to no, it's going to take the ball of that end mill past that profile. So if we had a flat bottom there, we're basically going to be gouging the bottom of our pocket or creating a trough all the way around the pocket floor. If that were the case, we could set our minimum Z to yes, and it's not going to allow the tip of the tool to go below the bottom of this profile that we programmed. So obviously you're going to have a little radius here based on your cutter, but it will not allow that tool to go below the minimum Z and gouge. You can do it this way by setting your minimum Z, or you notice on the part that we started with, the original profile. Let me go back a few screens here. On this one here, at the end of our profile, we programmed a straight line. That would essentially do the same thing. It would keep the tool from going below that endpoint. So you can do it either way. Either method should work for you. So that's minimum Z. The Z roughing that we have here, you'll have to forgive me for my artwork, but I'm going to go ahead and draw something here to try to explain this. What this wants to know is, say we were creating, this was our swept surface profile. If we're roughing this out using a peck depth, with Z roughing set to no, basically what it's going to do, it's going to go to your first peck depth, it's going to machine over, it's then going to follow this surface up, follow it over, follow it back down, and then take the rest of that peck. Then on your next peck depth, it's going to do the same thing. It's going to keep on going and follow that whole surface. That's with Z roughing set to no. If we set the Z roughing to yes, cutting the same geometry, what it's going to do, it'll take its first pass over. Once it hits, it'll kind of follow up the contour, and then it's going to retract, position over, come back down, go down the surface, finish that peck depth, and then when it comes in with the next peck depth, it'll go in, it'll just follow that surface up until it reaches the last peck depth, and then it'll retract, come over, and come back down. So Z roughing set to yes basically eliminates constantly tracing over what you've already cut. It speeds up the roughing a little bit. Go back to arrow here. So that's Z roughing. We're going to go in and walk through an additional part here. This will allow us to work a little bit with the pocketing in swept surface. Again, I'm just going to pull up my desktop software. going to create a new conversational program. I'll go ahead and put in some stock geometry. Looks like we're 4 inches in X, 3 inches in Y, and 1.8 deep. So I'm going to go in, input, art programming. Again, I'm going to go into milling. This time I'm going to hit more and go into swept surface. I'm going to follow the same process. I'll go ahead and start with my profile contour again. So I'm just going to select draw profiles, tell it I want to edit that profile contour, and I'm basically going to just define this arc here. I'll start at x0, z minus 0.3, so I'm starting right at this point here. Go to our next segment, it'll be an arc. It is a clockwise arc. I'm not sure on my y endpoint, since we're not going down to the same minus 0.3, so I'll just give it the minus 0.2 that I know for the z end. I'll give it my x center point, should be 0.3, and my z center should be minus 0.3. And it went ahead and calculated that x endpoint for me that I don't know. So that's it for my profile contour. Again, I like to work off the review screen. So I'm going to hit review. I'll just go right back to my swept surface. Tell it I want to edit the along contour now. Tell it I want to edit. And now we'll just go ahead and define this outer geometry. I will be cutting on the right side of this geometry. This is what I'm going to define. So I'll leave that set to right. My X start will just be 0. And I'm going to use blend arcs to create all of these radiuses. So I'm just going to go ahead and start someplace in the middle of the part. So start right in the center there at 1.5 inches. I'm going to go to my next segment. It's going to be a line. It's going to end at 0. Y end, I'll go ahead and take right up to the 3 inches. Next segment, blend arc. Going to another line. And my next segment will be a line that takes me right back to my Z start. Or I'm sorry, my point that I started this contour. So now we have, if I go to my review screen, we've got the along contour, and we've got our profile contour. So all I need to do is go into my swept surface parameters, set this to swept surface, and fill in what we need at in this data block. Start a little bit above the part. As far as a tool, I'm going to use a little smaller tool here. I think I had it set up as tool 4. Let's go ahead and select tool 4. I want to cut normal. I am going to go bidirectional, and we'll give it a step size again of 50 thou. So now on this part, if we draw it, see that we've got that swept surface created. However, the part shows that center pocketed out. We can very easily handle that in the swept surface data block. All we have to do is come over to the pocket tab. It's going to give us several options for pocketing. None is what we just saw, no pocketing. We can leave it as an island, meaning the swept surface that you've just defined will be an island in someone else's or some other data block's boundary. or we can set it as a pocket boundary, which just means we want to pocket out the center of that, which is what we want to do here. Or you can leave it as an island and a boundary. We're just going to go ahead and leave it as a boundary for now, so we don't have to create any other geometry. And then I'll just go give it a tool that I want to use for pocketing. I'm going to go ahead and choose a flat end mill for pocketing this out. We've got all the same options that we would have if we were doing a standard pocket. So now if I draw this, since I don't have this pocket first set to yes, it should go ahead and create the swept surface, which we'd be cutting quite a bit of material once we came over that surface. So in order to kind of eliminate that, I'm going to go into my data block and I'm going to tell it, yes, I want to do the pocketing first. And there's our swept surface. So you can see how you can add pocketing in with your swept surface as well. One other thing we kind of need to talk about, and that's those individual profiles. We'll go ahead and go here. I don't have a print for it, but I'll walk you through a simple example of it. Again, I'm just going to use a square block and apply different profiles to different sides of this data block. So we'll walk you through this and show you how to apply the different profiles. I'm just going to start a new conversational program. I'm going to go into stock geometry. And I'm going to tell it that I have a 4-inch by 4-inch by 1-inch block that I want to work with. Go into my part programming, go milling. I'm going to hit more, go into swept surface. So this time I'll go ahead and I'll do the along contour first. You can do either or first, since there's nothing really new going on here. Actually, no, I'm going to go ahead back. I was going to go into the along contour and create it first. As I mentioned, you can do either or, the along or the profile. It doesn't matter which one you do first. But we'll go ahead and we'll define the profile contour first, and we're actually going to create a couple. So I'll go into my draw profiles, and you see it's going to ask, do we want individual profiles? If I set this to yes, first it's going to give me just an informational message here that says something about the use of cusp height to determine step over disabled when using individual profiles. So it's just saying that we're not going to be able to use that option. Say OK. And now what we're going to do is we're just going to define multiple profiles. So I'm going to go ahead and start with this profile number 1 and just say that I want to edit the profile. I'm going to make sure that it says 1 up here. We'll just give it an X and Z start, and we'll go to our next segment, and we're just going to make it a simple line. Say that we end at X 100 thou and Z minus 3/4 of an inch. So we've got a profile which will basically put some draft on that wall. I actually want to go into my next profile now. So I'm just going to select my second profile. Tell it I want to edit that profile. And it still got me here. So I'm going to go in and tell it I want to do profile 2. Just by going to segment 0 of that first profile, it gave me the option of changing my profile number. I'm going to start it at the same point. My next segment will be a line. And let's say I end this at an 1/8 inch instead of a 100 thou. You can't get too crazy on these multiple different profiles. If I were to put one ending at 100 thou and X and the other ending at 3/4 of an inch, most likely the control will throw up an error because there's just no way for it to transition between those two contours. Also, your Z-end, if we're using multiple profiles, Z-ends have to be the same. Otherwise, the control can't figure out how to transition those two separate profiles. So we've got two profiles defined now. Press my review button. You can see that we have profile contour 1 and profile contour 2 now. I'm going to go to the swept surface, and I want to go edit the along contour, and I'm just going to define this geometry here. I do want to cut to the right side of what I'm going to program, and we'll just start a pocket that's a 1/2 inch in on all sides. I'm going to start right at 2. Okay, so we've got the along contour program now. One thing that I haven't been dealing with is you'll notice that it's asking me for the use profile number at the bottom of the segment. Oops, I'm not done quite yet. I think I started right in the center, so I'm going to have to go back to my next segment, program a line, and 2 inches. So now I should be good here. But you'll see that it's asking for a segment number on each one of these segments. So I'm just going to go all the way back to my segment 1. If you remember, segment 1 was this line here. It wants to know what profile do you want to use. I'm going to go ahead and leave that at 1. I'll go to my next segment, segment 2, which was this back line here. I'm going to tell it that I want to use profile 2 for that segment of the contour. Go to our next segment. Segment 3 was this line here. So I'm going to keep that on profile 1. Go to 2 for this segment. And then 5 will be taking us right back to the beginning, so I'm going to use profile 1 there. Going to go to review. Set this to swept surface. Let's say that we use that 3/8 ball, cut normal. Give it a step size. And we're going to tell it that we want to make this a pocket boundary. I'll use that flat end mill I used before and tell it that yes, I want to do the pocketing first. So when I draw this, you should see that I do have a pocket with draft angles. Now because they're so similar, it's kind of hard to tell on the screen here, but I am using 2 different profiles in order to create that. So I do have different draft angles on each of these different walls. And that's how you work with individual profiles. You don't use that one quite as often, and usually when you do, it's for something like this where you just want different draft angles on your geometry. And that is the basics of swept surface and 3D mold. As I mentioned before, if you're doing anything that's going to be revolving, typically around the x-axis, you're going to be using your 3D mold. If you want to do anything, pretty much anything else, you're probably going to want to go towards this swept surface. And once you get into it and start creating some data blocks, you'll notice that majority of the time you're not going to mess with a lot of these parameters, and if you just deal with what you need to deal with, you'll kind of lose some of the intimidation of the swept surface block. You know, there's a lot of different fields and parameters here, but on the same token, you've got a lot of options with the data block. You know, if you're going to have that many options and that much ability, you have to have the parameters to be able to support that. So that is the basics of swept surface and 3D mold.
Hey, Jason?
Yes?
We got a question real quick.
Okay.
Those first two parts you programmed, in the draw profile, you always have to start at the center of the arc? Is that what you were doing?
In the first two swept surface?
Yes.
Okay. Let me... I wasn't storing snapshots, so I can't remember what I called them. So I'm going to go to a previously programmed part just because I can see these here.
Either one of
So...
those, yeah.
So on this one here, ask your question again.
When you draw the profile, you always, if you start at the center of the arc, is that what you're doing?
I started at the end of the arc. Let me, and I can probably explain this on another screen better. Let me, forgive me for the jumping around here. There we go. Typically what you're going to do when you program your profile is there's going to be a point on that profile that is attached to your along contour. That's typically where you want to try to start. And I usually put that right at 0, 0.
Go one slide forward.
On the 3D mold or the swept surface?
Just where you are right now, just go one slide forward. That part right there, I think, is the question.
Okay.
You programmed your profile start at the center of that radius, did you not?
Yes.
My profile start, I actually programmed at the start point. You remember that I programmed this in the counterclockwise direction, and I started with the arc, and what I did, and forgive me for the artwork again, but basically that's what I programmed there, was just an arc going in that direction. The reason for that, the point of the profile that's going to attach itself to the along contour is going to be that point right there. And you'll remember that it doesn't want negative Z moves when you're defining negative X moves when you're defining your profile. That's why I didn't define it just as though we had here. So I wanted to start with the point that's going to attach itself to this along contour, but I also had to program it going in the counterclockwise direction so that I wouldn't have the negative X move. You know, if I would have programmed it just the way I did in 3D mold, it would have been basically the same thing, but I would have had a negative X move here, which
for simplicity's sake, couldn't you just do your profile start like on the other side there at X, whatever that would be?
Yeah, you could do that.
Okay.
You would then have to tell it you're cutting on the right side of your profile as well.
Okay.
You'll find that when you first start programming, you'll play around with it a little bit. Once you've done a few, you'll kind of start to iron out how you like to create the profiles. You know, as with any, I guess, new software, there is a little bit of a learning curve. And so I would imagine that your first few prints or parts, there will be a little bit of fumbling around with it until you kind of start to figure out what it's wanting to know and how it needs it. But you can see the basics of what we did here. So,
Do you have the program that comes on the machine as far as a sample program? I can't remember what it's called, but do you have that? Do you know what I'm talking about, Jason?
I know that there are some samples. Right now, I don't have it.
Okay.
I'm actually pretty happy that I made it all the way through the presentation without my my desktop software giving up on me. Yesterday, without really thinking about it, I downloaded some beta software for testing for the engineering group. So I was a little worried once I got started today that was going to jump up and bite me, but I don't have the samples.
Okay.
You have an operations manual. Do we have an operations manual for this?
Yeah, it's on. Yeah, the web surface programming comes on the disk with the machine, correct?
There is I honestly don't know if it comes on the disk or not. What I can do, there is a options manual, and that's where the 3D mold and swept surface information resides. Also, a lot of the information that was in this print, and forgive me for shuffling stuff around here, a lot of the information that was in this presentation, yeah, I'll bring that back up here in a second. But as far as the manual, we can get you the 3D or the options manual, but also if you hit the help button on your control, which is what I have here, of course, I wasn't in the 3D mold. If you're in a swept surface data block and you hit the help, it's basically going to bring up all the different parameters that you have to deal with. And a lot of the information that was in this presentation was taken right from this help menu. So you do have that, which is kind of like the programming manual embedded right on the machine, but we can get you the manuals as well.
Okay.
Oops, sorry about that. Minimize that. And let me just go ahead and...
Applications at Hurco.com.
Yeah, I'm bringing that back up here. I added this last minute, that's why it didn't quite display like I expected. Let me go to the end here. And there's the applications email. This is an email address that goes to all the applications engineers. Basically, when you send an email here, it goes in a folder that we all check through the day. Because of travel schedules, the applications department, 30 to 40% of the time are on the road, individually anyway. So to be able to catch whoever happens to be in the office, a lot of times the applications email is the best route to go, unless you need to speak with someone specific. Same thing with the applications phone number. This actually rings through to all the application engineer's desk. It'll start at one, and it rings a couple times at each desk. If it does happen to make it all the way to voicemail, it then sends that voicemail to every application engineer. So a lot of times the application's phone number is going to be the quickest way to get a response as well, just because you know that you're going to get someone in the office.
This is a great one. So that's all I've got for this here. Again, I know that you've got specific prints that you want to work on, and once you start working on those, feel free to give us a call. Either send us an email at the applications email, or use the applications phone number, or you can call my desk directly.
and we can go through that.
Okay.
But that's the basics of 3D mold and swept surface. I hope this cleared it up a little bit. And I think once you start using it, you'll find that everything just kind of falls in place. Especially like 3D mold, there's not a whole lot of options there. So, you know, typically you can work yourself through that pretty well. And then on the swept surface, there's a lot going on, but majority of the time, you are going to just be able to ignore a lot of that. So I would say just start working with it, and definitely let us know with any questions you may have.
We'll call you in about an hour.
All right, I'll be here.
All right, Jason, thank you, sir.
All right, thank you. We'll talk to you guys later.
All right. Bye.
Bye.